the top of page 27 describes how you'd go about solving this problem. So our problem is, which of these is equivalent, right? Which equation has the same solution as 12x squared minus 17x plus 6? So, first step, right? We see we have a polynomial, a quadratic, with an a that's not 1. There's a 12 in front of the x squared. Go over our hierarchy first. Is there a common factor between 12, 16, and 7? Can I pull out any number? No. Okay, check. Is this a special case? Is it a difference of squares? No, it's not, because literally a difference of squares has 2 terms. It says 3. Is this a perfect square trinomial? Probably not, because if you look in the middle, 17 divided by 2 is not a whole integer number. Right? It's not an integer number. Okay, so no greatest common factor, not a special case. Then we go to factoring. So we have to factor using our solving trinomials with a greater than 1. All right, so the first thing we have to do, so on top of page 27, go through the 5 steps. So the first thing we have to do, we need to take our 12 and multiply it to our c. All right, we're taking the coefficient in front of x squared and multiplying it by 6. What is 6 times 12? 72. Okay.
That's a big number.
Second step, we are rewriting our quadratic, but we will not have the coefficient in front of x squared, and we write our new c. Can you see my quotation marks? New c. Literally what my a times c was, right? 12 times 6, 72. Cool. Third step, go ahead and let's factor it. So let's think of factors of 72. But before we do that, they multiply to 72, which is positive, add to a negative. So we have to have 2 negatives, okay? So we realize we have to have 2 negatives. Because you add, it will give me a negative number. If you multiply 2 negatives, it gives you a positive. So there's a couple different things we could do. 1, 72, no, that's going to be way too big, right? -1, -72. Someone said -9, -8. That adds a -17, so those are our numbers we're going to plug in. So step 3, and these little steps, it is on page 27. The page I'm on, this is where the steps are listed. So I list out my binomials, x minus 9, x minus 8. Okay, step 4 says, wait, now you factored it, let's see what the real solution, real binomials are. Because remember, our coefficient wasn't just x squared, it was really 12x squared. So I had to put in 12 in front of my x's. And then I must go through in the 5th step of factoring. This is for factoring. We haven't even gone to solving yet, only factoring. But notice, the 5 answer choices just have it in terms of factor. They don't actually go through and solve. So, I need to simplify, aka reduce each. What is the greatest common factor between 12 and 9? What number goes into both? 3. Okay, let's divide each of these by 3. So, I have 4x minus 3. What number goes into both 12 and 8? 4. Okay, so this turns into 3x minus 2. Which answer is it going to be equivalent to? The last one, right? Both of them should be negative. Perfect. So, 2 people who have not submitted, we just said the answer.
I submitted, I probably got it wrong.
2 people have not submitted, 12 of 14. It's fine. So, although there's an easier way, you literally could look at these numbers and say, if I FOIL these together, 2 times 3 is 6, okay, -2 times 3 is -6, so if I FOIL the L of FOIL, the last one, it doesn't match, right? So this one would give me a negative, and I have to have a positive 6. This one would give me a negative. So automatically, I already know it's either the first or the last one. Process elimination. So this is a real SAT question. This is how you can go about it, so you don't have to do all of this work. Oh my gosh. You just look at the L. It's called bite-sized pieces. So this is a strategy called bite-sized pieces. You don't have to do the whole problem, but if you can figure it out using small stuff, that helps. So this gives you a positive 6, right? The L of FOIL, this gives you a positive. We eliminate these middle 2. Now I have to think, okay, so both 3 and 4 multiply to 12. The question is, I needed to add to -17. These are both positive. I have to have them be both negative. That way, the middle will be negative. So you don't actually have to do all this work. if this was the SAT. But of course, why did I pick this problem? Oh yes, so we can practice coefficients other than 1. That was the point of this problem. Okay, so I'm going to go ahead and close this, and we're going to do the second question. So remember the hierarchy we go through, right? What is the first thing we always check when factoring?
Greatest common factor.
Greatest common factor. Let's try it again with 100% participation. The first thing you always try is greatest common factor. Awesome. Greatest common factor. Do we have a greatest common factor? 6. So we have to pull a 6 out. So try this one out. When you're done, push submit. Yeah, greatest common factor. It's in all 3 of them.
It's both.
But then why?
I got you with that, boy.
I'm gonna go over it in a moment. Okay. So what I just wrote on the board is just like, hey, looking ahead. Today we're finishing the 3rd lesson. This is why on your lesson plan it says 2 days of review, because I knew we would need one of them. I just didn't know which lesson it would be for. But the majority of your packet is literally the 4.3 lesson because I put so much like practice and review on there for you. So looking ahead, not tomorrow, on Thursday, when we meet, we'll go over 4.4. Friday, go over 4.5. Next Monday, 4.6. Tuesday's review, and then the test is when you get back from Thanksgiving on the 3rd. Yeah, so the test doesn't change. It's just like, oh, I knew I would need an extra day.
Are we gonna have homework over the break?
It depends. Do you finish your homework as you go, or do you wait till the night before?
Wait till like
You wait till the night before, then it looks like you'll have a lot of homework over Thanksgiving.
What? And
It's so easy.
Yes. So there's 5 topics due in Alex this Friday. Guess what opens Friday? A 2-week span where 10 topics will be due. So it's not due on Black Friday. It will 2 weeks. It will be 2 weeks. Yeah, and you could be done for 2 weeks. Okay, so that's 10 people have already submitted the answer. Let's go over this. It's enough time. So the first thing we always try is to pull out a greatest common factor. Notice 6 goes into all of these. 6 goes into 6x squared, 6 goes into 12x, and 6 goes into 6. How did I get, what? Sure. Yeah. Okay, how did I get the negative 2x in the middle? Because it's negative 12. Negative 12 divided by 6 is negative 2. Okay, so now if I was trying to factor this quadratic, my coefficient in front of x squared is just 1. So I'm looking for 2 numbers that will add to negative 2, multiply to 1, right? So add to the middle, multiply to the outside. So negative 1 and negative 1. They will add to negative 2 and they multiply to positive 1. So wait, which one is it? The middle, right? If I label it, it would be C. All right, so 2 more people. Let me submit. No? Okay, well, I'll end it. Goodbye. Okay, so that was a little bit of review. We're going to finish section 3 today.
I think that's all.
No, leave it till the end. So we're on page 29, I think.
No, we finished that. We're on 30.
Sorry, we did difference of squares.
31.
We did difference of squares, so now we're doing perfect squares.
Yeah, we're on 31.
We're on 31.
31. Is this not 31?
31.
Okay, who's...
Not like big dog. Big dog.
Yeah. I mean, you want a spot, but yeah. Go ahead. When I come back, it's my spot.
Okay, let's start with these warm-up questions. Let's go ahead and let's factor. So, first thing, is there a common factor we can pull out? No. Not stupid. It's just, it's okay. We made a mistake. So, 4x squared minus y squared, is there a common factor? No. Okay, ready? Greatest common factor? No, can't use it. Is this one of our special cases?
Yes.
Yes. So, this is the order we go through every time. It's a special case. It is a
Difference of squares.
difference of squares. Difference, 5. Phew, cool. Difference of squares. So, difference of squares meaning, oh my gosh. I have two factors. What times itself is 4?
2.
What times itself is x squared?
X.
X. Okay, and what times itself is y? I'm sorry, y squared, y. Literally, a difference of squares gives me the same binomial, it's just the difference is the middle part. Adding it and subtracting it.
And that's the answer?
Yes, because we just have to factor. It just said factor. It doesn't say solve, just factor. We factored it, check, solved. So if we try
So this would be just 4x plus y, or what?
2x plus y and 2x minus y.
No, but for the next one.
Yeah. So give me 2 seconds. What if I would have x squared minus 4? I'm sorry, x squared minus 4. Remember, this should be a simple difference of squares. You would write it as
X
minus 4x plus 4.
2. X minus.
x plus 2, x minus 2. And the big thing is, literally, you're taking what times itself is the second number. What multiplied by itself is the first number. Okay, a little bit of a aside, a little review, so we can hit B. So I have x to the 4th minus 16. Jordan, sit up.
X squared.
So,
Would be x plus x squared plus 4x squared minus 4.
exactly.
And then can you simplify it more to
Yes.
where you do
So hold on. Don't lean back on your chair. First off, don't lean back on your chair. Got an email about how people are breaking chairs, and teachers are supposed to make sure they're not leaning back. Okay. There actually is. Okay. Yeah. Okay, so I want to make sure we understand x to the 4th term. If I multiply x squared times x squared, this is the same.
And then
Hold on, I'm gonna wait till there's quiet. I will wait. Okay. Rules of exponents. If you have the same base, what you do is you add the exponents. Do we remember this from Algebra 1? Okay. Just making sure we're clear why I broke it in x squared times x squared. Now, Kaden had a point, but wait, x squared minus 4, we just did up here. It is a difference of squares as well.
Yeah, what? So it's
So I have to break it into x minus 2.
x plus 2.
And is this the answer?
Yeah.
You have to make sure to write. You have to make sure to include the x squared plus 4 from our original. So what I did was I broke this part down.
I'm so
Wait, please. If you have a question, raise your hand. Let's be as efficient as possible. All right, done.
Why is it required to add the
Why is? Because it was part of the original factoring?
Yeah, isn't that also difference of squares?
No, it's not, because difference means subtraction. This is addition. Addition of squares.
wait.
And our next lesson would be, how do we actually break this down? So this is the reason we have 4.4, our next lesson, which is imaginary.
There's someone squared the answer.
Yes, but it deals with imaginary numbers.
That's scary.
Right, which we're going to cover next section. It's not scary. It's actually fine. Yes.
On the test, is there going to be an already factored problem you have to find its solution to the equation?
That'd be a good idea.
Oh, wow.
But no.
And it took me forever.
The practice test. Why do we? Okay. It's not me, it's you, and I will not feel bad. I'm trying to get over feeling bad, marking off participation. I'm just not going to feel bad. It's you, not me. Okay. So, if you look at the practice test, I literally changed numbers. It is so similar to the actual practice test. The test and the actual practice test, so similar. I need to go back and check that I didn't accidentally put a number, like forget to change a number.
Did you give us the practice test yet?
I already did. And I do have a couple extras, I think.
I don't think I have one.
Actually, I don't have any more because I gave them out already.
I think we only got the practice
Oh,
test.
I
I haven't.
have some of the.
Apparently, I didn't get it down.
Thank you.
Okay,
Got-
so the practice test, online. Solutions, online. Have been since the first day of the test, or first day of the lesson, of the chapter.
I got it.
All right, so let's do difference of squares again. Right, because clearly there is no common factor between the two terms, right? 16 is a perfect square, 81 is a perfect square. What do I mean when I say perfect square? Tall, what do I mean? Tall, what do I mean? Perfect square means? Felix?
I mean, it's like for 16 is 4 times 4, 81 is
It's a number times, so.
Awesome. A square is literally, if you have a number times itself, like 25 is a perfect square because 5 times 5 is 25. 81 is a perfect square because 9 times 9 is 81.
Squared, like,
So is it 4 times 4
minus
or 4 plus 4?
4x minus 9y, 4x plus 9y. Because if you think about it, what times itself is 81? 9. What times itself is y squared? Y. I'm going to get to your question in a moment. 4x. Okay, what? Doesn't matter the order. You can say 4x plus 9y times 4x minus 9y. Is that your question? As long as you don't switch the 9y and the 4x inside. Right? So since it was minus 81y squared on the right side, you have to have the 9y on the right side in your binomials. Because it has to be like the subtraction sign right here. You have to have the subtraction. It has to be, okay, to the right of the subtraction, you just stay to the right of the addition and subtraction. Okay, so that's a difference of squares. Literally, if you look at the two binomials, the factors, it's the exact same thing. The only difference, one's a plus in the middle, one's a minus. What if you have the same factor twice, like x plus 1 plus x plus 1? Right? If it's exactly the same one, you could literally rewrite this as x plus 1 squared. Now, this is, when you have a perfect square trinomial, the two factors, exact same. Exactly the same. Perfect square trinomials meaning both of these factors are the exact same. Perfect square trinomials are the times when you have one solution. Remember the parabolas that go down, touch the x-axis, come up? Those are perfect square trinomials. So if you look at the quiz I gave back to you, you may have had the version that had a perfect square trinomial. So if we try to factor x squared plus 6y, x squared plus 6x plus 9, think to yourself, don't say it out loud, what multiplied by itself, what two numbers multiplied, add to 6, multiply, go to 9, add to 6. 3 and 3. So I can write this as x plus 3 times x plus 3. Oh my god, I can't talk. That is true. I try to like touch base with people so if they're like lost, I can see. So I get the exact same expression. What about what two numbers multiplied is 25, two numbers added, negative 5 and 5. So the point for a perfect square trinomial, you're going to get the same factor for both. Both binomials will be the exact same. Also notice that, we said positive 3 and positive 3 over here, right? What is the middle number divided by 2? 3. Oh, and then you square it and it should be this one. So if I divide the middle number by 2, I get negative 5. Square negative 5 and you get 25. Ah. Huh? Yeah. So this is one way we can check whether the trinomial, because tri is 3, nomial numbers, 3 terms. Check if it's a perfect square trinomial. If so, factor. If it's not, we're done. Is a perfect square trinomial? Don't say it out loud. Think to yourself. Okay, is it a perfect square trinomial? If so, factor. Try to factor it yourself. See if you can find the two answers. Try to factor A. When you're done, try B. What do you think with B? Because you have to be careful, because I showed you that trick, but that's only if you have a coefficient in front of x that is 1.
So then can you just factor it regularly?
Well, it wants us to do a perfect square trinomial.
Oh, it doesn't put you go here. So what do you do? Like right now?
For B,
Yeah.
it may be perfect.
Do you always have to divide it by 2?
So that's like my quick and dirty trick of showing how to do it. This first one, you have to make sure your coefficient in front of the squared is 1. Alright, this is 1. So I divide by 2, I get 4, square 4, you get 16.
I don't know what adds.
So,
Yeah, that's hard.
Yeah.
No, this is prime. Because it's not like.
so this would be x plus 4 times x plus 4.
Instead of being
Alright, this one. So, this, I have a coefficient other than 1, so I move it over.
I thought you
And
only said this is equal to 0.
So I have a coefficient other than 1. I want to use my trick of taking the middle, divide by 2, and see if squaring it is the end. I have a coefficient other than 1, so I'm moving that over to see if it would give me the same factor. I want the same factors. Minus 30x plus 90. Okay, what is half? I'm going to wait. So much noise. Okay, what is half of negative 30? Negative 15. Do you know what 15 squared is? Is it 90? No, it's 225. You don't have to know it's 225 because 90 is close to 81. 9 squared is 81. 10 squared is 100. So this 90 is between 9 and 10 squared. 15 squared is not going to be between 9 and 10 squared. That is some math reasoning. My hope is by the end of the school year you can understand how to do that. So, it does. No. It just says determine whether each trinomial is a perfect square. Is this a perfect square? No. So while I could factor it, it's not a perfect square trinomial. We're checking if it's a perfect square. It's not a perfect square trinomial. So while I could factor it, it's not what we're looking for. Following the directions, it's not a perfect square trinomial. Let's do D. We're skipping C and we're going to go to D. We'll come back to C, but let's do D. So, is this a perfect square trinomial?
Yes.
Alright, because 9 squared is 81. You take the middle, divide by 2. 4.5 squared is not 81. So this is not a perfect square trinomial.
Oh.
Tricky. No, not a perfect square trinomial. Try out C. Try out C. Well, I could probably still factor this. Let me think. 81, 9, 27, 3.
Wait, try
I don't know.
Are we going back to
The
C?
answer is
4.5. Actually, this would not give me any real solutions.
Are we going back to work on C?
So, the directions for this problem states determine whether each trinomial is a perfect square trinomial. This is not a perfect square trinomial, so we say no. So this would be prime, so we would have to use quadratic.
If you double it, you get 2048.
First thing, what's the first thing we always check? Greatest common factor. Is there a greatest common factor?
Oh, yeah.
Yup.
Yeah, it works.
Okay, so I pulled out a 16. Is this a perfect square trinomial now?
Why plus
Wait, I thought you're supposed to multiply 16
Plus
by
4, sorry.
64.
No, you have to find the greatest common factor first.
Plus 4. Sorry.
You're supposed to multiply it by 64. But you can also divide
Okay,
it by
so, I'm going to say this one more time, but I need you to be quiet. So, the first thing you always check, Jackson, what are you doing? Stop messing with each other.
Check for the greatest common factor.
You always check for greatest common factor first. 16 goes into 64, 32, and 16. If there was no greatest common factor, like there wasn't in B, right? B, 9, 30, and 10 have no greatest common factor. That's why I had to move it over, multiply, so I could try to use my rule where you take half of the middle one square it and see if that equals the c, the end, because that would be a perfect square trinomial. B had no common factors. C, 16 is the greatest common factor for all my terms. So I could pull out 16. Okay. So now, do I have a perfect square trinomial? So you take the middle, 2, divide by 2, and that's 1. What is 1 squared? It's not 4.
1.
1 squared is 1. It's not 4.
Oh, wait.
Wait a second.
So it's not.
So technically, what? 1 squared?
Oh,
1 squared is 1. So you take the middle, as long as your coefficient in front of x squared is 1, take the middle, divide by 2, square it, and then you have your third. So this is more or less, I'm basically teaching you the whole chapter in this one section because it's just all like together. Because I have so much review, I'm actually teaching about completing the square before we hit section 5. It is what it is. That means section 5 should go smoother. So it's not a perfect square trinomial.
Always do this for, or are you gonna
This is,
specific ones?
so my goal of this exercise is to have you understand what it means to be a perfect square trinomial. But the way you solve, like using perfect square trinomials is section 5, called completing the square. Yeah. So the goal is recognize what a perfect square trinomial looks like. That way you can go down your list and like factor in order. You check for greatest common factor. Then you see if you have any special case. Is it a perfect square trinomial or is it difference of squares? Then you go through and try factoring. If none of those work, then you go to quadratic formula. Only then. Okay. On the actual test, right? You look at your practice test, it's exactly like what the real test is going to be like. I ask you, solve this one using factoring. Solve this one using difference of squares. Solve this one using quadratic formula. So I'm literally asking you to apply the specific steps.
On example 13, number A.
We're about to do it. We're about to do it.
Okay.
Factor each polynomial if possible. If it cannot be factored, write prime. So, first thing we always try. Greatest common factor. Is there a common factor?
Yes.
2. Pull out a 2. Now I have x squared plus 9. Ah, I see 2 squares, right? So this is a difference of squares? No. Difference means subtraction. Here I am adding. Can I factor any further? No, I can't. So I'm done.
So it's a no.
Wait. 9 square root, so can you factor x plus 3?
So if you think it's x plus 3, let's see what happens. You see x plus 3 plus x plus 3?
Yeah.
FOIL this out. Let's FOIL. So this is x squared plus 3x plus 3x plus 9.
Yeah.
Ah, I have 6x in the middle that there's not up here. No, come on. It's just like we're just trying it out. We're just trying it out. This is perfectly fine. This is a valid concern because people do this. People do this. In my pre-cal class, they mess this up. Okay, there's no 6x, so clearly that's not the answer. It's prime. I can't actually write it as a product of 2 binomials. All right, let's do C.
Would it be?
Okay, so no greatest common factor between 1, 5, and 6. We're done. Is this a special? Is this a difference of squares? No. Difference of squares is only 2 terms. Is this a special? Let's see. Perfect square trinomial? Well, 5 divided by 2. Nope. Okay. Then we're gonna try to factor, right? So normally it doesn't take too long. You should take like 1 second to look at it and see no common factors. It's not special. Go straight to factoring. What numbers add to -5 and multiply to 6?
None.
Let's see. So hold on. If you add 2 numbers and you get a negative, at least one of them has to be a negative. Yeah? Hold on. Reasoning. Let's reason through it. Shh. We're reasoning through it. Please. I'm happy you understand it, but I want you to understand it when I'm not with you. Okay, if you're adding 2 numbers and you get a negative, at least one of your numbers has to be negative. If you're multiplying 2 numbers and you get a positive and one of your numbers is negative, that means the other has to be negative because 2 negatives multiplied is a positive. So I'm trying to explain why we have 2 negative numbers. Because we're adding to -5, but multiplying to +6. When you multiply to a positive number, You're either going to have two positive numbers or two negative numbers. Whereas adding to a negative, so that means both of them have to be negative. So I have -2 and -3, and that, let's see, multiplies to +6. So I have x minus 2, x minus 3. And it just wants us to factor, and we're good. Try out C. Do we have a greatest common factor? No, no greatest common factor. So, hold on, do I want to do this one? 12 minutes. Okay, so I want to go to example 14, and if we have time, we'll come back to these other ones. Because 14 is like one that's on your homework. It's exactly like one problem that's on the test. And this is literally the opposite way of what we've been doing. If I give you a quadratic, and I have you factor it, and then take each factor, set it equals 0, and solve for the roots. Well, I give you the roots, so you have to set the roots equal to your x's, get the factors, FOIL them, and get a quadratic. Do you see how we're like going in the opposite order of what we've done before? So I'm going to write that on the paper as well. So, write the quadratic equation in standard form. This is a standard form for a line. Chapter 4 is about quadratics. So you're not using lines, we're using a quadratic. Standard form for a quadratic is ax squared plus bx plus c. This is standard form. I must have it in this form at the end. So I have two different roots. That means x equals -8, and my other root is x equals 5. So think about before when we were solving, right? We set each factor equal to 0, and then we solve for x. So what I'd like to do is, since I have a solve for x, I would like everything to be on one side, so I set it equal to 0. So we're going the opposite way of solving a quadratic. So I'm going to add 8 to both sides here. So I have x plus 8 equals 0. Subtract 5. So I have x minus 5 equals 0. So now that I have two binomials, right, these must be my two binomials that I can FOIL together to find my quadratic. So if I would take x plus 8 times x minus 5, that should equal 0, right, for my quadratic. FOIL it out. Do we know how to FOIL? First, x squared, outer, -5x, inner, plus 8x, L's last. 8 times -5 is -40.
Wait, hold on.
So do x to the first x to the 5, and then x to x.
Yep.
X squared minus 5x plus 8x.
And that's all in the form that you...
This is in standard form. It matches standard form. Yeah. So I'm going to leave it up here a second. I'll make sure you write it down. Give about 5-10 more seconds, and I'm going to summarize. Okay. If you think about it, so you read your paper from top to bottom. Now try to read your paper from bottom to top. You start with a quadratic, right? Then you factor it out. You set each factor equal to 0, and you solve for the roots. Oh my gosh, it's literally the opposite way we've been going over it. Hey, okay, let me try this again. I'll go to the board this time. So, I'm having you do the opposite way we've been doing it. All right, normally I give you a quadratic. You have to factor. You set each of your factors equal to 0. You solve for, maybe you have to subtract it here too. X equals -8. But you solve for x would be, you're solving for roots. So normally we go this way to solve for roots. If I give you the roots, you can go and find what the quadratic equation could be. So that's powerful because if I give you a graph, you have the ability to see what the x-intercepts are. And the x-intercepts are the same thing as the roots, the zeros, the solutions. If I give you a parabola and you can see the two x-intercepts, you can literally write the equation of the quadratic using those two roots. You don't have to go through and okay, here's my vertex and blah, blah, blah. This is a little bit easier.
And is it the side, it's on the side of the following, it's on the where to give us a parabola, and they were put it to the left.
So the -8 and 5, that means this graph would look something like this. So -8 is over, -8's over here, 5 is here, So that would be your parabola. So you'd be negative 8 comma 0. So you use x value of negative 8. 5 comma 0, you'd use a value of 5 for x. And then you set your x equal to them. You get it, you move everything on the same side, so it's equal to 0. You have your binomials.
What are you
Multiply
gonna
them.
like give us like graphs?
No, I'm literally just gonna tell you the two roots. That just makes it easier. But I would like you guys to see like how this all connects. What's wrong? You're brighter pink than his shirt. Okay. So write a quadratic in standard form with the given roots. Let's try this other question. So remember, we want standard form, which is ax squared plus bx plus c. That's what we're looking for at the end, quadratic. So I'm going to set each of my roots equal to 0. So I have x equals negative 2/3, and I have x equals 5/2. So what I'd like to do is move everything on the same side. So what I could do is I could go over here and I could add, don't write this, I could add 2/3 to both sides. So I could have x plus 2/3. But then we're going to have to FOIL and have all these fractions. No, I don't want to do that. A better idea. What if I multiply both sides by 3? So then I have 3x equals negative 2. And how do I get everything on the one side so it's equal to 0? Add 2 to both sides. Oh my gosh, this is so much better. Because then I'm left with 3x plus 2. That will be one of my binomials. Halfway. And then after we find the other, we FOIL them together and we'll have our quadratic. So I have 2x equals 5, subtract 5. So I want you to FOIL these two binomials together. See if you can figure out what the quadratic would be.
Whoa.
So remember, FOIL. Just go through the steps. First, outer, inner, last.
Oh, yeah.
First, outer,
Oh, you have to multiply.
inner, last. So, although I gave you roots that were fractions, I feel like it was doable, right? You just have to do 2 steps, right? Multiply both sides and then subtract or add. Okay, what questions do we have over this one? We can go back and still have about 4 minutes. We can go over some more examples. But this is one of the questions that will be on the test. What page is this? What?
This is hella crazy, like I understand it now.
This is literally page 33 of 42. We have 3 lessons left and only like 9 pages. So this was literally 10 or 15 pages by itself. It's a hunk of a lesson. Well, I mean, we still have 4 minutes, so we're gonna work for like 2 more and then you can put them away. What, page 32? Okay. So let's do E and F. Let's do E and F. We're gonna do E and F. E and F, page 32. It says factor each polynomial if possible. If it cannot be factored, write prime. So we're trying to factor it. So first, is there a greatest common factor? No. Is this one of our special cases?
Yeah, difference of squares.
Difference of squares. Because difference, and both these are squares. 4a squared.
Yeah, that's
Yeah.
just difference.
Yeah, difference of squares. 2 things are squares, difference of them, subtraction.
When you say special,
Special, there's 2 special cases. Difference of squares, perfect square trinomial.
okay, so those are what the special.
Yep. Okay, literally this is the list I'm going through. Whatever. Right here. Page 21. Page 21. This is what I'm going through every single time. Is it greatest common factor? Is it a special case? Can I factor it? This is what I go through verbally every time with you. It's page 21. Star it.
So Brian, one
Yep.
thing called when it's like perfect numbers and each other, like a 4x and a I forget, what's like the other negative one?
It's crazy, but
I don't know what you're
Difference of
saying.
square.
This-
Square root.
This is the perfect square trinomial, or the difference of squares.
Perfect square.
So this is a difference of squares because 2a, if I square 2a, it's equal to 4a squared. If I square 3b, that's equal to 9b squared. So it's a difference of two things that are squares themselves. So this would just be 2a minus 3b times 2a plus 3b.
That's it.
Yeah, we just have to factor. Versus f, okay, let's see. Is there a common factor I can pull out?
X.
No, because, all
Lies.
right, this doesn't have an x in it.
Lies.
Is it a special, it's not a difference of squares. Is this a perfect square trinomial?
No.
No, because this is a 1, right? If I divide it by 2, 1/2 squared is not 1. So it's not perfect. And if I try factoring, do I know any number that adds to 1 and multiplies to 1? 1
One
plus
and zero.
1 is 2.
1 and 0. That's 0.
1 times 0 is 0.
No.
Times
Non-existent.
Oh my god. Half.
No, just joking.
Prime. It's prime.
It'd be prime. And this would be where you'd have to use quadratic formula. Okay, so we're done with this lesson. Our next class, we're going to do 4.4, which is imaginary numbers.
Can we take this up?